Hi guys, it's Virginia. We're going to do a demo problem on the angle sum formula for tangent. And so these are the kind of problems you would see in homework 3.5b. So we're given the sine of angle A and the sine of angle B and the quadrant that they are in. So first we just need to get these triangles sketched out so we can see what values we have. So I'm going to quickly sketch that this is the opposite side, this is the hypotenuse, and then I need my triangle to close. So to do that, I need to take the square root of 36 minus 1, and we know that it's in quadrant 2, so this x-coordinate value is going to be negative, and it's going to be square root of 35. All right, so there we go. My triangle closes. I don't care about the cosine for this formula. I just need the tangent values. So I'm going to go ahead and just check my tangent value. It's equal to opposite, so 1 divided by adjacent, so that would be square root of 35. Oh, what did I do? Oh, gave me a sign error. Yeah, of course, because tangent is negative here in the second quadrant. All right, so angle B, we are told that the sine is 8/9, and it's going to be in quadrant 2. So opposite is 8, hypotenuse is 9, and the adjacent leg is going to be the negative square root of 81 minus 64, so that's 17. So great, my triangle closes. I just care about the tangent here. So the opposite over the adjacent is going to be 8 divided by square root of 17. Oops. Divided by square root of 17. And I'm not going to make that sign error again. It's also negative. Okay, so now we have these tangent values, and those are the only things we need for this formula. So we're going to switch over to hand calcs real quick and crunch these numbers. Okay, let's do these calculations by hand just because they're a little bit easier to see what's going on. So we have tangent of A plus B equals tangent A plus tangent B divided by 1 minus the product tangent A, tangent B. Okay, and we've already found these values from the triangle sketches, but I'll just copy them over here so we have them close by. Tangent of A is equal to negative 1 over square root 35, and tangent of B is equal to negative 8 over square root of 17. So using substitution with the general formula gives us negative 1 over square root of 35 plus negative 8 over square root of 17. So that's just substituting here for the numerator. And then all of that over 1 minus, and the product of these two negative fractions is going to be a positive fraction. So I'm just going to go ahead and evaluate that right away. So negative 1 times negative 8, so 8 over the square root of 35 times the square root of 17. And this value is going to come up again in the calculation, so I'll just do it off to the side here. So remember, the square root of A times the square root of B is equal to square root of A times B. So this is just the square root of 35 times 17, or 595. Okay, so because we have what is called, this whole thing here is called a complex fraction, because we have fractions inside of a fraction. And generally, when we have complex fractions, we like to try and simplify them further because they're just hard to work with. So in order to simplify a complex fraction, the way to do it is just to take and simplify the numerator and the denominator as much as you can first, and then to go ahead and divide. So I'm going to start with the numerator. Oops. Numerator. And here I need a common denominator because I have the square of 35 and the square root of 17. So I can't just add these fractions. So I'm going to go ahead and multiply these to find my common denominator because I can already tell that there isn't going to be some other nice least common multiple to use. So let's go ahead and do that. And we actually did that over here, remember? So that's the square root of 595. So this is our common denominator. Okay. So -1 over square root of 35. And to get a common denominator of this square root of 595, I have to multiply the top and the bottom by the square root of 17. And then I'm going to add to that -8 over square root of 17. And the missing factor in the bottom is the square root of 35. So this is the value of 1 that I have to multiply this term by to get this common denominator. And this is the value of 1 I have to multiply the first term by to get this common denominator. So now that I have that, I can go ahead and simplify it. The numerator becomes negative square root of 17, which is 1 times square root of 17, minus 8 times square root of 35. And then I'll write the denominator out with what we know it to be equal to. Okay, so this right here is our simplified numerator. And now let's go ahead and, in a different color, let's go ahead and take a look at the denominator. So separately, we'll take this piece and we'll do the denominator. All right, so here we have 1 minus, so 1 over 1 minus 8 over square root of 595. So looking at this and looking at this, our common denominator is going to be, again, square root of 595 is the common denominator. So this is equal to 1 over 1 times this strange, silly value for 1 here, minus 8 over square root of 595, and we don't have to do anything to that second term. So we end up with the numerator becomes square root of 595 minus 8 all over the square root of 595. This is as simple as we're going to get this piece of the arithmetic. So now we have this guy, and we can plug them back into our complex fraction here, and then see if anything jumps out at us. So let's go ahead and do that. So back to the original fraction using our simplified numerator and denominator. And we have, here's our numerator, negative square root of 17 minus 8 square root of 35 divided by the square root of 595. And then in the denominator, we have this stuff. So square root of 595 minus 8 divided by the square root of 595. So it still looks pretty ugly, but there's one thing that should pop out at you, and that is that both of these terms have the same denominator now. And that's actually going to work out really nice for us when we do the next step, which is to multiply by the reciprocal. So remember, we're dividing fractions, and so we need to multiply by the reciprocal. So when we multiply by the reciprocal of the denominator, it's going to cancel. So what does that look like? It looks like negative square root of 17 minus 8 square root of 35 And then this becomes square root of 595 divided by 595, square root of 595 minus 8. So as you can see, this value now cancels with this value over here. And that makes it really easy for us to just go ahead and we don't have to do anything here. This just stays the way it is, and this just stays the way it is. And now we have an expression that has only one term, and it's not a complex fraction anymore. So it's a lot easier to look at, to read, to work with in future algebraic manipulations. So this is the best kind of answer to get for these kind of problems. If you put the original complex fraction into the tool, you might get 50% credit, and that is to prompt you to try and see what you can do to turn this expression into something that looks more like this, that's easier to work with. So let's go ahead and plug this into Math and see what happens. All right, so we have just calculated our formula, or our answer, and let's go ahead and check it in the Math tool. So we had negative square root of 17. And then I need to get my cursor out from underneath the radical, and then it is minus 8 square root of 35. Now, if you are the type of person that likes to always rationalize your denominator, you might have simplified this differently than me, and you'd get a slightly different looking expression, but the ultimate value, the numerical value it crunches out to, would be the same. So don't worry if it looks a little bit different because you rationalize the denominator. And then my denominator here is square root of 595 minus 8. All right, and let's go ahead and check that. And we got it right. So I hope that helps going through step by step. Just take it slow and try and find a common denominator every step of the way, and just reduce those complex fractions to a single fraction if you can. Thanks.